Good afternoon, good morning, depending on where you are in the world. Thank you very much for joining our first webinar. I'm Thomas Hexner. I'm coordinating the OpenRiskNet project, and therefore it's my turn here to introduce or to welcome you. I'm really happy that you are all here. Listening to this first broadcast, which will be mainly given by Alan and Tim from the Informatics Matter, one of our partners in the OpenRiskNet project. We will continue these webinars with a couple of scientific and more technical presentation. The first one is definitely a more technical one. But as I said, there will be more coming, more going into the case studies, how to use the services we provide. Somebody who is not familiar with OpenRiskNet, just one sentence. OpenRiskNet tries to provide services, which means data as well as software for the risk assessment in a very interoperable way, which means that you can use different services from different providers, which are consortium partners, but also third parties, and then use them in a very easy form to provide workflows, more complex workflows. As I said, this is a really one sentence. Perhaps it's complicated if you really didn't hear anything about OpenRiskNet before. But please visit our website, and I think then it becomes more clear. Today we are looking at how this infrastructure can be deployed, which means you can take it into your own company and run these services on your computers, and this is what Tim and Alan will present today. That is all what I wanted to say to start this webinar. I'm looking forward to hear the presentation, and I hope that you also enjoy it as much as I will. Thank you very much.
Thank you, Thomas. So I'm Tim Dudgeon from Informatics Matters. I'm going to give you an introduction about the OpenRiskNet the infrastructure and how we deploy it. Then I'm going to hand over to my colleague Alan Christie, who's going to show you this in action. So what is an OpenRiskNet virtual environment? So the virtual environment is really at the core of the infrastructure, and we've gone into this before in previous presentations, so I won't go into it in too much detail here. I'll just point out really the key differentiating factor of a virtual environment is that it's something you can deploy to your own infrastructure. So it comes to you rather than the traditional model of someone setting up a big website and with some systems in it, and then you having to go to that site. The virtual environment is different. You can deploy it into your own infrastructure where you are in complete control of it, in complete control of the security and the configuration and the setup of it. And what we're going to be describing today is how you can set that up yourself, so that you can go from sort of 0 to nothing in a matter of minutes, really, and have your own environment set up and running. So this virtual environment will sit on top of some sort of hardware. It could be physical hardware, often termed bare metal servers, or it could be cloud servers, either sort of private cloud or public cloud. It doesn't really matter. We're flexible and we can deploy it onto a number of different hardware environments, as you will see. So the OpenRiskNet virtual environment sits on top of that. And deployed into that environment out of the box is a number of what you can think of as infrastructure components. So infrastructure for applications, so things like databases or message queues that your applications might want to use. Monitoring to allow you to find out what's going on your cluster and find out when disks are getting full and things like that. Security infrastructure, allowing you giving you a single sign-on system and certificate management and things like that, and a full continuous integration and continuous delivery system for building your software and deploying it and getting it up and running. In addition, into the virtual environment, you can deploy the applications that the project partners have provided. Some of these are listed there, but there are many others as well. And we can deploy some third-party applications such as Jupyter notebooks and things. And of course, from your point of view, the key thing is you can also deploy your own applications into this and benefit from not only the infrastructure components, but also the existing applications that come from the partners and from third parties that have already been sorted out and are deployable. So a few examples of some OpenRiskNet virtual environments. The one you might be familiar with at the moment is the OpenRiskNet reference site, which we use for demonstration and testing purposes. It's open to the public. You can just come in, log in, and sort of kick the tires and find out how it works. So that's the best place to go if you want to find out what sort of beast it is. It's not designed for production workloads. For that, the expectation is you would deploy your own virtual environment into your own environment. We also have a development site and a couple of sites that are run by the OpenRiskNet partners for their own purposes. But probably the most interesting virtual environment is one at the Diamond Light Source at Harwell in the UK, where they needed an environment to manage their software applications in the area of fragment-based screening, and particularly the follow-on chemistry on that. And they decided that the OpenRiskNet virtual environment was the ideal basis for this, not only because they would have access to all the OpenRiskNet applications, but they could deploy their own applications into it and benefit from everything. And there on the right-hand side is their key application called Fragalysis, that they use for the chemistry follow-up on their fragment screening, and that's again a public service. You can actually go and look at that as well if you want. It's not restricted to the users of Diamond. It is publicly accessible. So what is one of these virtual environments? Well, it's based on software tooling called OpenShift, which comes from Red Hat. It's effectively Red Hat's distribution of Kubernetes. So what is Kubernetes? Well, Kubernetes is a container orchestration platform, and it's primarily backed by Google, but also a large number of other IT heavyweights in the arena. So it's as we say, it's a container orchestration platform. So what are containers? So containers are a way to package and deploy software. So package software and deploy it in an isolated and controlled manner. It was made popular by Docker, and most people, when they talk about containers, they think about Docker containers, but there are other sorts of containers that can be run, and those are becoming increasingly important. As I said, it was made popular by Docker because they made the tooling to make this really easy. Containers go a long way further back than that. They're really part of the Linux operating system. What Docker did is sort of tame this, get it under control, and make it easy to use. Because of that, they became very popular. So what a container is a way of putting your software into that container and running it on a Linux host in an isolated manner. So another container running alongside it could be running completely isolated from the first container. So at this stage, we'll break off, and we've got a quick poll for the attendees. We want to get an idea of people's familiarity with containers. So prior to this presentation, we've got some questions now of what your level of expertise with containers are. So could we show this poll right now? Now, there are 4 options, and it's a single choice. You just choose which one is right for you. We'll give you about 20 seconds or so to fill in your choice. First one is before this presentation, you didn't know anything about containers. Second choice is you knew about them and you were planning on looking at them at some stage in the future. The third option is that you're already using them, but for development purposes. And the fourth option is you're using them in production. So if you could all fill in that poll. And Lucian, when we're ready, can we show the results of that? Last chances to fill in. Okay, can we see the results now? Okay, so it's fairly evenly split. The majority, the biggest pool is the third one. So people are using containers, but primarily for development. Some people are using them for production. Some people are planning on looking into it, and some people didn't know what containers were. So that's interesting to know. So thank you for your input there. So let's go back. We've explained what containers are, and let's go back up, walk back up the tree here. So we now know what containers are. How does that apply to Kubernetes? Well, running one container or a small number of containers on one host is relatively straightforward, just using the standard Docker tooling. But when you want to do this at scale, you need to run this across multiple servers, and that then becomes an issue. Docker do have their own solution for this called Docker Swarm, but around about the same time, Google came out with Kubernetes, which is a more comprehensive solution for this and seems to have quite a lot more momentum in the sector. So Kubernetes is a way to run containers at scale across a cluster of computers, and Kubernetes handles things like the scheduling of the containers and making sure they stay running. So if a container crashes, it gets restarted. If a server crashes, the containers running on it gets rescheduled to another host and things like that. You can think of it as a distributed operating system for containers. So that's what Kubernetes is. What is OpenShift now? So as we said, OpenShift is a distribution of Kubernetes. It is 100% Kubernetes, but Red Hat adds some additional components to it to make a more complete package. And those extra things are important to us, which is why we chose it. So just to highlight three particular things that OpenShift provides over and above what Kubernetes does. It is a supported packaged bit of software from Red Hat. You can use the open source version known as OKD, so you can do that for free of charge. Or if you're an organization who wouldn't even dream of using a bit of software unless you can get a support for it, you can go to Red Hat and pay them for a support subscription and get the support you need. So it's the best of both worlds. You can use it for free in an open source manner, or you can pay your money and get a fully supported setup. The second thing of importance that it provides is it hardens the security. There are a number of ways in which it tightens up the security over and above what Kubernetes has, and obviously that's very important if you're going to be using using Kubernetes in any sort of environment, let alone a commercial one. And the final thing we're going to highlight is that it provides a full continuous integration and continuous delivery stack, allowing you not only to run the containers, not only run your software, but also build it. So you can go all the way from the source code, compile it, package it, test it, deploy it into a development site, and then push it into a production site. The CI/CD stack that comes with OpenShift, is pre-built and ready to do that for you. So a brief history of how we got to where we are today with the OKD Orchestrator, which we're going to show you. At the beginning of the OpenRiskNet project, University of Uppsala had a tool called KubeNow that was already being used to deploy Kubernetes clusters and was being adapted to deploy OpenShift. Based on what we learned from that and building on the good practices that established, we created a separate OKD orchestrator that was designed specifically to orchestrate an OpenRiskNet virtual environment. KubeNow is more of a general tool, and there are other tools you can use to deploy Kubernetes as well. But OKD Orchestrator is specifically designed to deploy an OpenRiskNet virtual environment and not do anything else. Just as a heads up, the OpenShift version 4 is coming out this year, and the deployment and orchestration aspects of that seem to be greatly improved over what exists today. And it looks to us quite likely that these orchestration tools will replace a significant part of the OKD orchestrator in the fullness of time. But as things are today, we believe the OKD Orchestrator is the best way of getting up to speed with an OpenRiskNet virtual environment. So how do you go about doing this? There are a number of steps you would have to go through, not all of which are covered in this webinar. The first one is to plan your needs. You need to plan out what sort of hardware you need in terms of the number of servers, the number of CPUs, the amount of memory, the amount of disk space, and things like that. That's just sort of working out what your requirements are and working out what you need to meet those requirements. The next thing you need to do is you have to set up some aspects of the networking. You need typically you need a couple of public IP addresses and a couple of host names, DNS host names that are that point to those IP addresses. You need to know those in advance before you deploy your cluster. And then step 3 is the main part of what we're going to see today. It's to run the orchestrator, and that really comes in 4 different stages. The first stage is to define a configuration based on steps 1 and 2. Once you've done that, you would need to compile your machine images if you're running in a cloud environment. These are your virtual machine images. If you're running on a bare metal environment on pre-existing servers, obviously you don't need to do that. Stage 3 is to provision those virtual machines from the machine images that have been built. And again, of course, you don't need to do that if you're using existing hardware. And then stage 4, which you always would need to do, is to deploy OpenShift. And Alan's going to show you this in a bit of detail in a short while. That gets you a cluster up. You would then typically want to do what is often referred to as day 2 operations. That's things like setting up backup protocols and things like that. And then once you've done that, the final step is to deploy the applications. These would be the OpenRiskNet partner applications, or maybe third-party applications, or your own applications. So this webinar today is concentrating primarily on steps 2 and 3. We may well run another webinar in the future that is concentrating on deploying applications. So where are we in terms of the types of deployment that we support? Well, here's a matrix. Across the top are the platforms. There's bare metal, so deploying onto pre-existing physical servers, and then 3 cloud environments: OpenStack, Amazon Web Services, and Google Compute Engine. And then going down and then the y-axis is, or the rows, we've got a compact environment, which is just a single server. Everything runs on one single server. That can be a big server, so it can do you can have a reasonable amount of capacity, but obviously it is going to be limited in the scalability. The one we're going to see today is what we call a standard deployment, which is much more scalable because it scales across multiple servers. And the final one is high availability. The difference between standard and high availability is that with standard, there are a number of single points of failure for various parts of the system. So if those parts go down, then your cluster goes down, and you've got to fix it before your cluster is working again. With high availability, there is redundancy of those critical components, and if one server fails, another one will just step in and take up the work. And so you should you are much less at risk to failure of any individual component in the high availability setup. The keys are, we've got 3 pluses. It means we've already done a reasonable amount of testing. When we've got 1 plus, it sort of should work, but we haven't tested it that much yet. And for the high availability, you see, we haven't actually got onto do that yet. It's one of the remaining tasks that we expect to do before the end of the project. In terms of cloud providers, we may support other cloud providers if there is a big demand for that. But we think with OpenStack, AWS, and Google Compute Engine, we've probably got a large amount of it covered. So I'm going to finish now. Just a few acknowledgements. Firstly, all the project partners who are listed on the left, and in particular to our 2 technology partners, Red Hat, who have helped us on various aspects of the technical aspects of OpenShift, and the Swedish Science Cloud, on which our production and development sites are running. They're providing the infrastructure that runs the production, the reference site and the dev site that we've just seen. So I think that's it. There are a number of links here that will be available, covering a large number of aspects of this. I won't go into this in any detail now, but these slides will be made publicly available, so you'll be able to look at all of those links yourself. So at this point, I'm going to hand over to Alan, who is going to actually show you this in action.
Okay, so our demonstration here is the orchestration of a cluster, in this particular case on AWS. As Tim mentioned, there are a couple of prerequisites here. So one would assume that you already have an AWS account and you are likely to have set up some static or elastic IPs in AWS speak. These are pre-allocated addresses that you get from your provider and that allow you to route a domain to an IP address. So one presupposes here that you've set up at least 2 IP addresses. You'll need one for connection to the OpenShift console for administrative purposes, and another connection which goes to a router that allows your customers to route into your applications. So you've got a couple of IP addresses that you've set up there. Okay, the orchestrator is all open source in a Git repository. I think we've sent those links out already, or they will be available. What I've got here on this right-hand screen essentially is a window on the Git repository for the orchestrator, where you can see all of the code and the files that we'll be going through today. And there's some built-in documentation, which is conveniently linked to on the main page here. So if I'll just click onto GitHub Pages, we're taken to the main documentation for the orchestrator. There are several sections in here and that go into some detail, and there are links through it, but we've created an orientation page, which is a self-contained description of the entire process and takes us through orchestrating to AWS. So that's the page that we'll be looking at today. I'm not actually going to orchestrate live. That comes with some risk in that network problems get in the way, and also orchestration takes a number of minutes, and we really don't have time, sadly, in half an hour to actually bring the entire cluster up. So I've already orchestrated it and made a recording of the console commands that appear, and they'll all be distributed. So the orchestrator is essentially a utility designed to simplify simple Red Hat platform installations. And by simple, as Tim pointed out, it's really just some nodes, not high availability, but it's a very opinionated way of installing the cluster. So you don't have fine control, but the whole purpose is to simplify the installation so you can get up and running with a full-blown cluster relatively quickly. And there are four stages, which we will go into later. The orchestrator is built on top of Packer, Terraform, and Ansible, and these tools are widely regarded in the industry of being very good at automating processes, but we don't need to know anything about those because the orchestrator comes with a couple of Python-based command line utilities that essentially manage the execution of those underlying tools. If you want to recreate this orientations deployment, you will of course need an AWS account. You'll need Git on your laptop to clone the repository. Ideally, you'll need Docker, because the orchestrator conveniently runs inside Docker, and you'll need Python. But we're not going to go through the setup of your system here. These are all documented in a link that you can see from this orientation page. There's a getting started guide, which hopefully guides you through preparing a system for orchestration. So why do I need the orchestrator? Well, you don't. You could just install everything yourself. You just need an OpenShift inventory file and some hardware. But to create an inventory file for OpenShift, which is actually quite a complex piece of software. There are lots of components, lots of parts, and a myriad of configuration parameters that really make your head spin. And I'm sure if you've tried to install somebody else's software, you can appreciate that. It's not that there's anything wrong with it, it's just immensely complicated. And quite often it's not knowing what parameters are essential and what parameters you can omit. But nevertheless, you can create an inventory file yourself. And you can create your own hardware. You've either got it already installed, or you can go onto the web, your cloud provider's console. AWS, for example, have a console. I've got one open here. And I can go into a dashboard, and I can click on here, and I can create instances by pressing buttons. But all of that is manually very intensive, and every cloud provider is different. So you know what a security group is in AWS, but it's a firewall in GCE. And often Google and Amazon are connected differently. You connect security groups to instances in AWS, but firewalls are connected to networks in GCE. Just another headache. The good news is that if you're tied to one provider for business reasons or some such, then at least you don't have to worry about too many learning curves. You just have to understand one cloud provider. You then go onto your cloud provider, clone the OpenShift repository, you switch to a tagged release, you install Ansible, you run the installer. That's all you have to do. But the orchestrator tries to eliminate a lot of the complexities we've seen here, because I've installed a number of these OpenShift platforms, and everyone is manually quite intensive. So we basically decided to automate the whole thing. The OKD Orchestrator tries to eliminate these complexities by consolidating all of the configuration into one human readable configuration file. It provides a simplified deployment, so it doesn't give you control over everything on OpenShift, but just what we think is important to get you going. And it tries to make the process cloud agnostic, so you don't have to worry. Your configuration file isn't that different on AWS as it would be for Google. And it also supports some advanced features, like as Tim mentioned, if you've already got your own hardware or bare metal, then you can still use the orchestrator for that, following the basic steps here. Okay, so how do I use the orchestrator? It's normally executed using a Docker container launched from within the project. The Docker container is essentially a batteries included approach, because I mentioned before we have the orchestrator depends on tools like Packer, Terraform, and Ansible. We don't want you to have to worry about installing these tools and getting the version right. So we have built a Docker container which is everything included. So you get Python and all of the tools conveniently installed for you. But if you're comfortable working from your own copies of the tools and Python virtual environments, you can run it from the command line. So we'll be exploring the basics of the orchestrator by reproducing a built-in configuration that we call the standard AWS deployment. And this one happens to be deployed in Frankfurt. I've got the configuration file open to the left, and we'll walk through that in a moment. So once you've cloned your orchestrator, we're then ready to follow the 4 basic steps to getting the cluster up and running. And here I just illustrated the basic commands to clone the orchestrator and move into it. So the presumption here is that you've got Git available on your machine and you're able to run Docker. As I said, if you haven't got Docker, you can still use the command line, and that is documented elsewhere in these files. And just follow the getting started guide. Okay, defining our deployment essentially requires us to create a number of small files. There's a configuration file, which we call a deployment configuration, which uses a very high-level language. It's YAML, where you describe your cluster in very high-level terms. you have to create some environment variables in a separate file. These are essentially secrets, your access keys to your provider and things like this. The configuration would normally be put into revision control, and you can see some of those in the orchestrator. And the final thing is obviously to have access to a set of SSH key pairs that the orchestrator will deploy and use to communicate with the hardware that it creates. If we look at a deployment file that I've got the standard example open on the left here. It's a YAML which provides you with the ability to name and describe the deployment, but it essentially contains two sections. One entitled cluster, where you define the hardware requirements of your cloud system. Here, the essential variables basically allow me to describe the region that I want to deploy in. Most cloud providers have multiple regions and multiple zones. So here I'm deploying to Central, which happens to be Frankfurt. I've also set up some domains. As we said earlier, you need some IP addresses. At some point, you need to communicate, you need to log into the console. So you would normally have some domain that you created, and these are registered and pointing to the IP addresses that you've already created in your cloud provider. The orchestrator doesn't create the IP addresses for you. It assumes that you've got a pair of fixed IP addresses that you'll want to use. And then it moves into a section of hardware definitions that are really quite lean. OpenShift has the concept of masters, infrastructure nodes, and compute nodes. So in this particular case, I want one master node, one infrastructure node, and 3 compute nodes. And I can also define the types, the number of CPUs and memory that are required. And here for AWS, I add the elastic IP allocations that I've already created that I want attaching to the master for console access, and the other IP address through which the applications will get connected. But essentially, that's the cluster definition, just master, infra, node groups. There are some other values that we can put in, but for the purposes of this demonstration, that's all we need. There are also environment files. I won't go into them here, but there are some templates inside the orchestrator that give you examples of the environment variables that you need to set. And these are typically your cloud provider key, passwords, and so on. And of course, an SSH key pair. We're not going to go into the detail of how you create the key pair. That is documented under the Getting Started guide. So we'll assume that you've got some key pairs, you've set up an environment file, and you've created your deployment as we've got here. So step 2 is compilation of a machine image. I've got some pre-recordings here. These steps take a number of minutes. I think I recorded them at the weekend. So compiling machine images takes about 10 to 20 minutes. So I'm going to kick that one off now. And this is a console recording of my execution of the compilation stage. Here I've set up my environment variables. I'm entering my container with a convenient OKD start shell script. So I've entered a complete development environment. If I pause that there, the OKD start, move down, as illustrated here, is a convenient shell script that launches a Docker container for me on my development machine. So I'm immediately in a Unix environment here with all of the tools installed. And then from within the convenience of that container, I have a command line, and I move on to running the other commands. Compiling is just running a build command as illustrated here, and that's what's taking place in the background. I just increase the speed of that so it finishes in an acceptable period of time, so we don't have to wait for that. Meanwhile, here's a diagram which is sort of illustrates what's going on. I'm running a Yakka build command, which is interacting with my cloud provider based on environment variables that I've set up and my deployment. And it's essentially creating a tiny compute machine on the cloud in order to install an operating system and configure that operating system. This isn't completely essential. You could configure the operating system for each node as it's installed, but if you're creating large clusters, that can be rather time consuming. So this compilation step is effectively creating a convenient binary image for a Unix operating system onto which we will install OpenShift. Here it's the process is completed, and you'll see that the output of the build process is a machine image, and that is stored in your cloud provider. If I go to EC2 and I look at my machine images, these are the images I've already built. So basically just snapshots, binary images that can be used to create a server. Our next step is to enact our cluster part, the cluster part of our deployment. So I'm going to provision all of the hardware based on this deployment definition here. And that's simply, again, entering into the same container. And instead of running a Yakka build, I just run one of the Python commands that the OKD Orchestrator gives us, and that's create cluster. And you name the deployment configuration that you want to create. So I'm going to run that here. And I happen to be outside of the container when I started making this recording, and there you can see, again, I'm just using OKD start to enter the container environment. I then run the create cluster. It asks me conveniently, are you sure? And away we go. Now we're not going to watch this, even though it only takes a few minutes, but essentially what is happening now is that the Orchestrator is using a tool called Terraform to build my hardware. So it's enlisting the help of Terraform to build hardware on AWS and configure their connections, the drives, and IP addresses and what have you. The output of this, the side effect of the provisioning, is not just the hardware, but it's an inventory file, which is important for the OpenShift installation. It's basically just a description of our hardware topology and a copy of the orchestrator. So as well as my OpenShift hardware, it's creating a Bastion machine onto which I will move in order to execute the final part of orchestration. Let me speed this up now so that we run a lot faster than real time. Bear with. Take my word for it, but that was a real deployment there that happened yesterday, but just 30 times real speed. And it concludes with an essential piece of information, and that's the IP address of the Bastion that it created on my behalf. Remember that I created 2 IP addresses that I wanted connecting to the master and infrastructure nodes of OpenShift, but the Bastion is a dynamic machine and it's created an additional IP address for me so I can hop onto that. What we have here is a summary of all of the components that the provisioning step has created for me on AWS. Not only has it created machines, it's created volumes, private gateways, routing tables, network address, translation machines, VPCs, subnets, security groups. It's generated an enormous number of objects simply to satisfy my cluster. And all of these are essential in order to create a compute instance that you can communicate with from the outside world. So you can appreciate how much time we've saved by just enlisting the help of Terraform and our deployment configuration. I can hop live to our console here to show you just what's being deployed. I happen to have the running instances. They're all tagged VRE simple. So here you can see all the compute instances that were created. You can see security groups that create. Not all of these security groups were created by the orchestrator. Some I had already, and some are provided for you by default for AWS, but we're only using those tagged VRE simple. And there's a VPC for those of you familiar with networking. So it's created a simple VRE, it's created routing tables, it's created internet gateways, all of this lovely stuff, which honestly makes my eyes glaze over, because at the end of the day, I just want to run some software. But I'm just illustrating what's gone on in the background in essentially a few minutes of provisioning. So that's done. We want to deploy OpenShift OKD now, the real subject of the presentation. Sadly, it's only a small part of the presentation. So we move to the final deploy stage. Now, importantly here, I am moving from my host. If I move back up, orchestration was run in a Docker container on my host machine up to this stage. When I install OpenShift, I'm moving to the Bastion machine that I created as part of the OpenShift deployment here, the Bastion configuration here. The reason why I'm doing this is because a number of compute nodes do not have public IP addresses. You cannot connect to them from the outside world. They can communicate with the outside world, but you can't connect to them. That's fairly normal practice in a secure network environment. These might be data. We might eventually use these for databases or application components that we don't want to see from the outside world. And nevertheless, OpenShift provides you with sophisticated routing so that the IP address that we'd allocated for our applications is how we get into our cluster. And that all of network traffic comes in through the infrastructure node and then gets routed internally. But nevertheless, I have to move to the Bastion for the final stage. But that's relatively simple. As you can see, the Bastion address is conveniently displayed for me. So I just have to move to that machine. The orchestrator not only has provisioned them, but it's also installed the orchestrator on the Bastion and all my configuration there. So if I run the final step, which is essentially SSHing to the machine, let's speed this up. Now, let's make this go really fast because the final step is the most time consuming. So what we're seeing here is the orchestrator enlisting the help of Ansible, which is an automatic configuration tool. Ansible is how OpenShift is installed, and it is just installing OpenShift for us. That's all we need to know from here. And that process, depending on the size of our cluster, takes typically 20 to 30 minutes. We're only a few seconds away from our imaginary deployment here. There are thousands upon thousands of operations that take place as part of deploying OpenShift. The final stage, OpenShift has conveniently added a user for us that we've defined in our configuration and run some extra software. If I move to the second part of our deployment configuration, I should have done that earlier, apologies. The provisioning step enacts our cluster definition. In the same file, I've defined what I want for OpenShift. I just happen to have OpenShift version 3.11 here. The most important thing is that I'm enabling some built-in tools that OpenShift provide. There is a metrics tool. Prometheus is a metrics and reporting framework. I've also generated some API certificates automatically in the background because I've set this field. And what the orchestrator has done for me is created SSL certificates that I used for the website. So now that's all done, I can go to the domain, the URL that I'd already configured. So here's my VRE informaticsmatters.com that I asked it to set up. And if I go to there is the front page of OKD installation. I can log in with the user's password, which of course I'm not going to know unless I go to a console. Anyway, I will pause for a second because I've realized that I'm not armed with the console. And I'm not going to try and do it now, which is one of the reasons why I pre-recorded this. Essentially, what we've got is an OpenShift server here that's been created by our orchestrator. That's it. So although there have been a number of steps, I hope that one thing that's come out of this is that the number of interactions that you have to make are very, very small. Apart from creating one inventory file, you're just running a create command to create the cluster and one command to orchestrate. There's further documentation that you can navigate through here, but I think that concludes a rather rapid demonstration of installing an OpenShift cluster.
Okay, so thanks, Alan. That's a great demo of how it all works. So what I've just wanted to finish with is giving you an idea of what you end up with. This here is the OpenRiskNet reference site that I mentioned earlier, and this is a fully functional OpenRiskNet virtual environment that was fired up quite some time ago. It wasn't fired up with the orchestrator. It was fired up with sort of earlier sort of versions of it, but effectively you end up with the same thing. So here is what we're seeing here is an application that is running in the OpenRiskNet VE. It's an application itself, and it's providing just a reference point where you can link out to all the other applications that we have deployed. So all of these applications that are listed here are now running in the OpenRiskNet environment. We've not shown you how these were deployed. That's a topic for another webinar in the future, but this is what you end up with. You've got all of these applications deployed, available, and ready to use. You can go to this page, you can try these applications yourself. So in summary, is this process easy? No, it's still not easy, but we think it's a great deal easier than it would be without this tooling, without the orchestrator. Is it useful? Well, we certainly hope so, and the people at the Diamond Light Source have certainly found it useful so far, and we hope other people will as well. But to get an idea of this before we go to questions, we've just got a final questionnaire here. So Lucian, if you could just fire up that final questionnaire. This is to get some feeling from you on what the interest would be in this. And this one is actually a multi select. You can actually select more than one answer here, but some of these answers are not compatible. Particularly, it's the last one that's important, really. Here, the last one says, yeah. Well, we'll go through them. First one, I'm not interested. Second one, I'd be happy to run to use a managed multi-tenant environment. So this is, you don't have to set this up yourself. You're just provided with the OpenRiskNet VE virtual environment into which you can deploy your software, but it will be deployed alongside other people's tools as well. Third option is, no, I need my own environment and I'd want to run it in-house. Fourth option is, I need my own environment and I'd run it on the cloud. And the fourth option is, if you chose 2, 3, or 4, yes, I'd like to do that, but I think I'm going to need some help with it. So you can select one of 1, 2, 3, and 4. And if you selected 2, 3, or 4, you can also choose the fifth one as well. So hopefully that made sense. And if you could all fill that in, we'll give you another sort of 10 seconds or so to make up your mind. And then we'll see the results. Okay. So I think you're all seeing this, but we're seeing 18% say not interested, 36% say they'd be happy in a multi-tenant environment, 45% of people are running in-house, 27% said they want to run on the cloud. I think we've got, rather, not sure this adds up to 100%, and 45% of you think you'll need some help, which I think is not too surprising here. So that's very useful feedback for us. So that's the end of the presentation, and we've now got about 10 minutes left before the end of the webinar. Let's see if we've got any questions.
So can you hear me now?
Yes.
Okay, thank you. So hi, everyone. Now, I was just wondering, so the infrastructure you demonstrated allows me to install some tools. So some are pre-installed, I guess, or not, I don't know. This is also a question. And anyway, let's suppose I install some tools, then there might be some outputs from a tool that are useful inputs for other tools. Can I move in a seamless way information from one tool to another? Can I create chains of tools, or I have to do it manually? And the infrastructure is simplifying the installation of tools.
Okay, the infrastructure is really designed around simplifying the installation. And to answer your first question, yes, we do have mechanisms for deploying the applications, but we weren't covering that in this webinar. That's the topic for another webinar. But to answer your main question, one of the aspects, the key aspects of the project is integration integration and interoperability between the different tools from the different partners. So that's one of the key aims we're trying to do. So you can take some data in, you can take one tool that might be generating some data, and then you can use that in another tool that could be using that data to generate, let's say, a predictive model for that. And we also have deployed into the infrastructure a couple of workflow tools that are designed to specifically facilitate that sort of thing. So it's the overall project is definitely designed. It's not really a function of the infrastructure itself, though.
So there is some way for me to create chains by programming them in tools that are already in the infrastructure when I install it.
Yeah, that's right. And a typical example would be to use a Jupyter notebook to do that. So you could use Jupyter to define, first step is to read some data from somewhere. The second step might be to process that.
So extraction, transformation, and loading of data, I have to do it manually by creating some scripts in the Jupyter notebook so that information can move from one tool to the other.
That would be one way of doing it, yes.
Okay. Now it's clearer, the thing.
Okay, so do we have any other questions?
Yes, so there is another question from LucasArt that I answered already, that if the webinar recordings will be available. Yes, they will be available soon on the website. Then we have another technical questions. Do you have rough estimation how many hours of maintenance for a developer would be needed to keep it running on the cloud? And how often do you intend to provide updates? This is from Eugene.
Oh, maintenance. How much? That's really how long is a piece of string. The infrastructure itself probably doesn't need much maintenance, but if you deploy lots of applications to it, then each of those applications could need some maintenance. It's a bit difficult to give a simple answer to that question. And in terms of updates, yes, we do plan to continue to maintain this, certainly through to the duration of the project and probably beyond. As I said, there are further parts of the code that we still need to do, particularly the high availability setup. So we will be continuing to enhance and maintain this. As I said, with OpenShift 4, some aspects of the orchestrator may become redundant and will be replaced by what's provided out of the box, but other bits won't be. So the orchestrator will remain in one form or another.
But I see that maintenance for a given deployment is very, very low. For AWS, for example, one expects the hardware to be extremely resilient. And I certainly have found that. And OpenShift is a very good platform at recovering from failure. So if a node were to reboot or you to lose it, there's very little maintenance required. OpenShift will try its best to get your application up and running on another node. So in terms of maintenance for a given release, it's very, very low. In fact, I don't envisage, apart from having to recover from cloud provider issues, It's just running containers. Anyway.
Yeah, but don't overlook the maintenance of the applications themselves.
Yeah.
Yeah. Okay, and do we have any other questions?
No questions, so that's it.
Okay, so we're nearly up to the hour. All I can say now is thank you all for attending. I hope it was useful. And if you've got any further questions or want to discuss anything more in depth, just get in touch with us and we'll do our best to help.